Hello everyone, you get video Bingley today while I'm away. I'm in Ogden at a math teacher's meeting, so I'm sorry I'm missing a critical lesson with ellipses and hyperbolas, but that's where we're at. As I start this, I'm not sure how many videos there will be. Short videos upload a little bit faster, so it will be some shorter videos. So here's the first one, starting with 5.4 ellipses. So we left off in class here on Friday, standard form of an ellipse. So this ellipse here has the equation x squared over a squared plus y squared over b squared equals 1. Information that you need to know. A is greater than b. If that's the case, that means that the number underneath the x squared is bigger than the number underneath the y squared. If that happens, you have a major x-axis. Remember, your major axis is the longer axis here. So it means you have a horizontally oriented ellipse. If, let me switch pens. If b is less than a, then you have a major axis along your x-axis. And that means you have an ellipse that's oriented vertically. Now, the equation that relates A, B, and C, if you'll remember, A, B, and C, here's the equation that relates them. A is the distance from the center to the vertex, B is the distance from the center to the minor axis endpoints, and C is the distance from the center to the focus. So how do we relate those? We're going to use that, but go ahead and solve for C. Just another way to write this. If I square rooted both sides, I'm solving for C. So if A is bigger than B, C is equal to square root of A squared minus B squared. And if B is less than A, then C is equal to the square root of B squared minus A squared. Now, the order of this A and B doesn't really matter that much because you're just finding the difference of those two values, A squared and B squared. And since you're squaring them and subtracting them, I don't know. I guess the point is, though, that your bigger number is the one in front. So the formula doesn't really change other than whatever your bigger number is the one that you subtract first, because you don't want to take the square root of a negative, but you're really just finding the difference between A and B. So yes, the first term underneath the radical is the bigger number, and the reason for that is because you can't have an imaginary number. Okay, so let's go ahead and finish that information in a box. And let's do an example. Okay. So, first example. X squared over 16 plus y squared over 9 is equal to 1. I want you to analyze this. What is the center? Where are the vertices? Where are the foci? And then I want you to graph it. What I would encourage you to do is pause the video and actually try to find these things, and then check your work and see if you're right. But of course, if you're stumped and don't even know where to begin, don't pause and just keep going. So here we go. The center, we haven't learned about these being a different centers, but you can imagine that what's coming up next is that we move the center to different coordinates like that. So that's coming up next. But since we don't see that for this problem, our center is just going to be at 0, 0. Then our vertices and foci and graph, I'm going to go ahead and work on the graph in order to get the rest of it. So here's my graph. Since this number here is bigger, I'm going to be oriented along the x-axis, so I have a horizontal shaped ellipse. This number here represents the a value. So a is the square root of 16, so a is 4. Remember that in the equation this is a squared and b squared. So a is 4, b is 3. It's going to be important for us to find c. So then come back up here. C is the square root of the bigger number squared minus the smaller number squared. So that is the square root of 16 minus 9, which is the square root of 7. Okay, so what does all of this tell us? Well, here's our center over here at 0, 0. A is the number along our major axis to the distance between the center and the vertex. So we're going to go over 4 units here and 4 units to the left. Those are our vertices, so they are at 4, 0 and negative 4, 0. The B value represents the minor axis point. So I'm going to go 1, 2, 3 and 1, 2, 3 here. And so those are our minor axis vertices, which are important for the graph, but not actually on this list of things that are needed. So we can go ahead and graph this. And then the foci are a distance square root of 7. Square root of 7 is like 2 point something, 2.7 maybe. I'm not sure. You could put that in your calculator. And the square root of 7, so that's going to be over here, 2.7-ish and negative 2.7-ish. I don't need the 2.7. That was just to help me with the graph. For the foci, go ahead and leave it in the square root of 7 form. So this is square root of 7, comma 0, and then this second point over here is negative square root of 7, comma 0. And we did the graph. Next example. Find the equation of the ellipse. So find equation of the ellipse given that it has a vertex at 0 plus minus 8 and foci at 0 plus minus 5. So I want to find the equation, but in order to find the equation, I'm going to start by just looking at a graph. So my vertex is at 0, 8, so I'm going to say this number right here is 8, and here is 0, negative 8. And then my foci are part of the way along, so this is 8, this is 5, negative 5. So if this is where my vertex is in a vertex and my foci, then that tells me that my ellipse is oriented vertically. So I can go ahead and draw in a rough guess of what that looks like. Right now I don't know what this point here is or this point here is. Okay, so the general format is to recognize that this has a center at 0, 0 again, and because it is oriented vertically, the number underneath the y is going to be bigger than the number underneath the x squared. Equals 1. Okay, A, B, and C. A is the distance between the center and the vertex. So A is 8. So that means that this number here is 8 squared, which of course we can write as 64. B is the distance from the center to the smaller axis vertex. I don't know what that is. And C is the distance from the center to the foci, so that distance is 5. So now in order to relate these three numbers and find B, we're going to say that C squared equals bigger number squared minus smaller number squared. And A, oh, I wrote that backwards. So that's going to be, no, that was right. 8 squared minus, I don't know what B squared is, and C squared is 25. I wrote that wrong. I apologize. Back up. So c squared equals the square root of all this. Sorry, c squared equals this. If I take the square root of this, I don't need the squared. Sorry to confuse you right there. Okay. So here we go. This is 8 squared minus b squared. This number here is 5. So square root both sides, and 25 is equal to 64 minus b squared. That gives us b squared is 39. So b is equal to the square root of 39. Now, this value here is that number squared. Square root of 39 squared is just 39. So this is 39. I'm going to clean this up and just write a 64. And that's it. There's the equation.